Most rainwater filters require constant cleaning for them to work correctly, and without that, they can clog up. But there is one type of filter which automatically sheds debris, and it's called the Coanda filter. Now, it's mainly used for hydroelectric systems where water is collected and brought down a good vertical distance and then released through a small nozzle or more than one nozzle at high pressure to drive a turbine and then generate power from that. And in those systems, a clogged nozzle can cause a huge problem, so a good self-cleaning filter is pretty important. Now, the Coanda filter solves this by using the properties of water to its advantage to bring as much water as possible and also prevent debris from contaminating the system. So I thought it would be an interesting challenge to design and test 3D printable versions with the goal of having a near zero maintenance rainwater filtration system that can be used at anyone's home that brings in the good stuff and keeps out the bad. So is a functional 3D printable Coanda filter possible? Stick around to find out. I've designed and used several rain barrel setups in the past, and the main issue I was having was that my filters were constantly clogging up with debris. Now, the most basic design is just to have a hole in the top with a screen on it, and that actually works okay, but it lets light into the barrel, which allows algae to grow, and then some small insects can get in there and actually lay eggs as well. Small sticks stems from trees, small rocks from asphalt shingles, and bugs and leaves and all sorts of other kind of random things that end up on your roof get embedded into the screen and clog it up. Now, there is a system called a first flush, which I actually really like, but the first flush also has a filter and requires constant cleaning for it to function properly. This is going to be water used for watering plants, so it's fine to have small particles. They're not going to cause any problems in my case. I'm shooting for filtering out anything larger than about 0.5 millimeters in size. So in a normal filter, as the water passes through it, the mesh of the filter will stop larger debris from getting in, and over time, depending on how dirty your roof is, this can clog up your filter, reduce your flow, and so that water won't be able to pass through that filter very quick, and it may end up overflowing near your home. Now, a bigger filter is a good idea to help with this, but I think it's actually better to try and avoid the problem completely if we can. And I don't want to have to cut the trees down around my home to solve this problem, so we have to go to the next possible solution. In a normal setup from a river or stream or a pond, a Coanda filter works by funneling the water through a narrow passage. Then it changes the angle of the water so it travels down on a slope. Using these filter fins, it then shears off a small section of water, if you will, and little by little, as it continues down that path, the more the water is gathered. Because the fins are spaced so close together, it only allows small particles through, and water of course as well, so it won't clog up the system, and the water is also effectively being pulled into the filter through the Coanda effect, where water wants to follow along a curved surface, and debris will tend to want to continue along its path until it gets to the end, and eventually, hopefully, make its way off of the filter. So this is one that I've designed, and it's similar to the standard Coanda filters, but with a few modifications to allow it to work with a downspout. Probably not a good idea to test this in the workshop. I think we should probably bring this outside. So I mounted the straps to it so I can temporarily suspend this and test it out. And then we'll see if there's any changes that we need to make and how well this thing actually works. So let's get outside. So here is our setup. I have a little bit of a downspout on the top. That's just to kind of simulate what you'd see with the water as it comes down from your house. It's not going to be perfect, but it's better than me just spraying right into the top there. As we go down, we can see a little bit of a deflector. And the reason for that is to try and send some of the water from the front backwards so it has the best chance of getting captured in here. We have our little rungs, fingers, or slats, and they're set at a slight angle. And that way the water that comes from the back is sheared off just a little bit. And anything that's missed is going to travel to the next one. The exact same thing happens all the way down. Any water that's remaining that may not be captured can still come around the front. And there's a little bit of a gap there, slightly larger gap here than on the top. And the reason for that is because hopefully any debris is already on its way off of here. Not 100% sure if this is going to work or not, but that's the idea at least. And when that water wraps around, you can see how it is able to get into the downspout on the bottom side of this. So I think it's time to test this out with some water from the garden hose. And if that works fairly well, you can always test it out with some debris here from the yard. There is a little bit of water that's wrapping around the front here. Some of it is not going into the gap. It's kind of riding along the side of the acrylic there and running down here. Other than that, not too shabby. So I think it's time to try out whether this would actually shed some of that debris automatically, or if it would get stuck in here, or if it's just going to go down into the bucket. So let's check that out. So I'm not quite sure how to do this the best, but what I think I'm going to do is just stuff some debris in the top. Trying to pick stuff that I think would actually end up on the roof. So things like leaves, some twigs. So I put a whole bunch of stuff in the top, and obviously it all got stuck in here. The interesting thing is that even though that's happened, it actually seems to do a better job of collecting the water. So when this happens, the water doesn't come off of the end. It almost immediately gets captured in here. Kind of diffuses the water as it's traveling down, it seems. So that's kind of interesting. It actually performs better with a bunch of junk in there. Yeah, so it looks like a few of these twigs are stuck in here. So this design actually doesn't work too bad, but what I've noticed is that when the water's coming down, there's a fair amount of water pressure or water above to force it in this top section here. And it'll go in really easily here, but as soon as the water comes out and there's nothing above it, then it seems to want to ride along the surface. But I think we can do quite a bit better, so I have done another design. We have a little bit of a difference in the angle. We also have quite a bit more length. But the biggest difference is actually down here. So rather than have this wrap right around, I just have a fairly straight lip and a bit of a drip edge built into that as well. And one more thing, I've also made this opening larger, and I've also changed the radius on the inside there. It's a little bit more gradual than it was in here. And that way it still sends the water a little bit towards the back, but there's more room in here for the material to come out. Oh, there's a little bit of water coming off the edge. So as I increase the amount of water, I'm getting eaten alive here by mosquitoes. As I increase the amount of water, quite a bit coming off the edge here. Still, it's capturing quite a bit as well. So I'm going to put some leaves and sticks and junk in the top. Okay, so not too bad, but we're still getting, oh, a little stick there. This is actually a twig from one of the leaves. So not too bad, but you see there's quite a bit of water still coming off of the front edge here. So that's not really ideal. I would prefer, if there's still gonna be water coming off the edge, that it go down the pipe and then down to where it was draining before. So that question led me to a completely different type of design that used the same type of feature, but it's in a spiral or in a cone shape. And it has a ton more surface area on the inside, but it also has some other benefits like we just talked about, where the excess water, if there is any, will continue to go down the drain. Basically, it is this idea, but taking complete advantage of the fact that the water is already traveling down from the downspout vertically, and we can use that, I think, to our benefit. So I've created this somewhat conical, twisted shape, which is exactly this same shape, but it just wraps around. And part of the reason that it's twisted like this is just so that it's a bit easier to print. It kind of looks a bit like that old barber sign when it twirls around. Kind of mesmerizing. And there's an outlet here, and I can attach a pipe into that, and that can lead to a rain barrel, for example. So this has magnets in it, which is using the same kind of magnet technique that I use pretty much everywhere. So you can rotate this for different setups. This side, you can see I have an adapter that fits my downspout perfectly. It has those magnets in there as well, which match up to these magnets on the top and also match the magnets on the bottom. Those bottom magnets don't serve a purpose at the moment, but eventually I can reconnect something like this and then connect the downspout to continue on from the bottom, or maybe some way of just capturing some debris or something like that. I don't quite know what I'm going to do with that, but I thought I would make it that way just so it could be modular. Now we just need to get this outside and get it tested. So the idea is that the water is going to come down the downspout, and it's going to hug more or less to the outside of the downspout pipe. That's just a theory. I don't regularly look down the inside of a downspout pipe to see what's happening during a storm, but I believe that it's sticking to the pipe, and that way when it comes down here, it's actually going to continue to be around the outside, and it's going to want to go inside here. Now inside is that same shearing action layer after layer. So one layer, it's going to shear a little bit of water off. It's going to come onto this outside surface here, and that's a curved surface, and it actually overhangs the outside as well. So as it's coming along here, it's going to draw in more water. It's also going to spill down around the outside into this cup at the bottom, and then hopefully out here. Now, all of the debris, hopefully, will come down here and just pop right out the bottom. That is actually working really good. These magnets didn't quite go all the way in, so the bridging that was on the top there, I left 0.5 millimeters. It obviously took up some of that gap, so I couldn't push this completely together, and some of the water's coming out the outside. But you can see how much water is flowing out there. That's actually working really well. I wasn't expecting that. Let's try that a little bit more, but closer up, and maybe we'll even do some slow motion video. That is working awesome. So there is some water coming out at the bottom, but it's actually because I'm spraying it with the highest spray setting from my nozzle, and some of that water just will not, it's not slowing down enough to get captured. But that's perfectly fine. And actually, I kind of like that idea because some of the debris will want to come out there if there's still some water coming out at the bottom. So I'm perfectly fine with that. I just want the majority of the water to be going towards the rain barrels, and the rest of it can come out the bottom and go to where it was going before. It's capturing the majority of the water right at the top. It doesn't even have a chance to get down here below. So this probably could even be shortened if I wanted it to. Now, part of the idea behind this design was that eventually it could be maybe put up like this. So if you want to disable it, you can just have it coming down this way and the water would come out here. Now, there's a little bit of a problem because this hole is a bit too small, so it needs some sort of a funnel attachment. Maybe they can be magnetized to that as well. Let's go ahead and put some debris in here and test it out. Whoa, okay. Some of it already came out. Yeah, there's still lots in there. Stuff that back in there. I didn't see much coming out. Nope, not much coming out. Let's try it with a little bit less. Yeah, whoa, I stuffed it full, okay. Yeah, that would be a problem. Let's try that again with something a bit more reasonable. Okay. Oh, it's pretty good, but there's still some debris stuck in there, so it's not working perfectly. So it's probably tapering a little bit too much. Yeah, judging how well this works, I don't actually think much of a taper is needed at all. It also probably could be shorter, but other than that, it's actually pretty clean. If you look at the inside, there's one stick going kind of horizontal. So I've gone ahead and made some changes, and now it looks like this. So the original, quite a bit taller. The new one, quite a bit shorter, and the reason for that is because it didn't seem to need all of that length. There's another change too, pretty big one, in that I removed most of the taper. You can see there's a lot larger hole in the center than in this one, so this one should have a lot less issue with things getting stuck inside. And the other cool thing with this design is that now I can flip it upside down, and that means that this will cease to actually work as a filter. Take it out, flip it upside down, and you can see that taper in there, so it'll guide it in, but it'll avoid that collection completely. At least that's the hope. Let's go ahead and get this mounted and test it out. Seems to be working pretty well so far. Let's put in some junk into the top. A couple little sticks stuck to the inside there, but overall, all of the big stuff is gone. Even better. Yep, it seems to be self-cleaning just fine. There's a couple little pine needles that are stuck on the inside there, just fitting barely in between, so they're a little bit tricky. So let's try it upside down, and I don't see any way the water can come out of here. It should just come right out the bottom. Good, a little bit of water is coming out at the joint. That's again because the magnets don't seat completely all the way in, but it seems to be working just like it's supposed to. I think the vertical coil style Coanda filter, which I'm calling the Anna Kanda filter, not only looks a lot cooler, but is much more purpose built for the water that's already moving straight down. The modular setup also allows it to be easily modified and removed for the occasional washing out right at the rain barrels. One problem that I had was with the seams, so I ended up changing to random seam locations, and that helped to solve that problem. Still there a little bit, but it's much better than it was before. Since this is just a prototype, there's still lots of room for improvement, so let me know what you think about the system and if you think something like this is worth putting more work into, or if you think there are other better options out there too. For anyone wanting to try this themselves, I have the 3x3 downspout adapter, and I also have a 2x3 adapter that I've created. And if there's other sizes, please let me know and I can whip those up and post them as well. I'd recommend PETG or ASA because it's going to be outdoors all year long. And I've used the acrylic tube available from Bambu's Maker's Supply on Maker World. And I've also started to use these 20x10x3 rectangular magnets from Maker's Supply as well. And I prefer those over the cylindrical ones now because I can keep the walls pretty thin and still have a pretty good attraction as well. To attach the parts, I think silicone might be a better choice than the super glue as well. I will have links to everything that you're going to need down below if you want to make a set yourself. So is it possible to 3D print a functional Coanda filter? Yes, it is. And actually it works really well, definitely better than I was expecting. Now all I need to do is cut some logs to make the raised stand for my rain barrel so we can start to test this out on a real setup. So I hope you enjoyed the video and found it interesting. And if you did, please consider giving the video a like and subscribing if you want to help support this channel. I'd really appreciate it. If you want to help support the channel in a different way, I have a short list of products that I use in my shop every day that I know perform well. That's down in the description below. Thanks to my patrons for helping to support this channel. Take care, and I hope to see you on the next one.